Welcome, my name is Daniel Ordonez and I will present our workshop abstract paper, Morphological Symmetries in Robot Learning, where we summarize the theory and results of our last paper accepted to the conference Robotics, Science and Systems 2023. To understand the concept of a morphological symmetry, we will start by examining the simplest case, the reflection or sagittal symmetry. Roughly speaking, this refers to the property that some dynamical systems have to imitate the spatial reflections through physical discrete changes in the state configuration. A key characteristic of a morphological symmetry is that it represents a physical transformation of the state configuration. In other words, we can always reach the symmetric state of a morphological symmetry. The reason why we are interested in these types of symmetries is because they not only manifest in morphology, but also extend to symmetries in the system dynamics, optimal control policies, and all proprioceptive and exteroceptive measurements. The symmetries in dynamics become apparent through the equivariant nature of the system's equations of motion. Simply put, this implies that any set of motion trajectories originating from symmetric states will remain related by the same symmetry transformation through time. Notably, a dynamical system with an equivariant dynamics has equivariant control policies as optimal policies. As before, this implies that any set of optimally controlled trajectories originating from symmetric states will remain related by the same symmetry transformation through time. Last, due to the equivariance of the dynamics, morphological symmetries extend to all proprioceptive and exteroceptive measurements. This implies that for any data measurement that we obtain from our robot or from the environment, there exists a set of symmetric measurements we can infer with no additional cost. This property applies to all relevant measurements in the fields of robotics, computer graphics, and computational biology. So, the goal of our work is to provide the theoretical abstractions required to generalize the concept of a morphological symmetry beyond the trivial reflection symmetry. Among the various symmetric systems we study with our proposed formalism, the quadruped robot solo stands out with its eightfold symmetry. One of the most significant practical implications of the robot symmetry is the remarkable realization that for every minute of recorded data during the robot's operation, we can effectively obtain an additional 7 minutes of recording simply by exploiting the robot's symmetry group. Moreover, in terms of learning, any experience gained from one of the symmetric states of the system can be directly applied to the other 7 states. In other words, for this robot, learning the skill of walking forward automatically implies learning the skill of walking backward, regardless of whether the robot is positioned belly up or belly down. As our time comes to a close, we encourage you to read the paper and explore our poster to gain deeper insights into the implications of morphological symmetries in data-driven methods, control theory, and computational design. Lastly, if you are interested in experimenting with morphological symmetries for learning applications, we invite you to visit our repository, where we are actively growing a library of symmetric dynamical systems and provide tools for symmetry exploitation, including data augmentation and equivariant neural networks.